Namaskar, Adab, Shat Sri Akal. Welcome to the live course in group theory on YouTube. And in this lecture series, we have already discussed about groups, subgroups, okay, and their properties. And Lagrange's theorem has been discussed already, I think in lecture number 10. You can check the playlist. And after that, we were discussing properties and concepts of permutation groups. Do you know why? Because you can see that we have written the problems on Lagrange's theorem. So what is a Lagrange's theorem? Certainly it has been discussed already and we will recall it tonight. Certainly we will recall it and we will try to do problems on this also. But before coming to the Lagrange's theorem, I would like to say that in the previous lecture we had seen that the converse of Lagrange's theorem is not necessarily true. I mean to say it may or may not be true. So in which condition it will be true and what is the counter example? So a very beautiful counter example is from permutation groups. So that's why we were discussing all those things in the previous lecture, because all types of groups were discussed in the beginning of this course, but permutation groups were remaining. So that's why I had taken two small sessions on that, and from tonight onwards we are going to continue our lecture in group theory. Certainly we will start this session with a question on cosets. We will try to understand the geometrical description of cosets, and thereafter we will go ahead with some questions that will certainly build our concept. So I would also like to say that on this channel I have already completed real analysis. Yes, more than 90 videos, more than 100 hours, and complete syllabus for CSIR NET, GATE and exam is over here on this channel. So check the playlist Priyatan CSIR NET and you will be able to see the clear-cut concepts, a two-way communication, and almost all type of questions that is used to ask in CSIR NET, GATE or exam. So now here is a very first question in front of you. Maybe you will watch it recorded, but you must try this question for sure. Okay, this question is very basic. That's why I have written concept builder over here. You can see it's a concept builder question for cosets. So you have to find the distinct left cosets of this H. Okay, 1 and 11, two elements are there, and this 1 and 11 has been taken from U30. Okay, so this is the group Z, this is your H, which is the subgroup of this group Z, and then you have to find all the distinct left cosets of H. Okay, so how shall you find it? It is really interesting to see. So you must try. Okay, no matter you are watching it recorded, you must try, and if you will be able to do it, then certainly it means the concept of cosets is clear a bit. And I would like to say that what is this U13? Okay, we have already discussed about this group UN. So we will certainly write the elements which is less than 30 but co-prime with 30. So you will not hesitate to write the elements of U30 as 1, 7, 11, 13, and thereafter 17, 19, 23 and 29. We have already discussed about everything of the group UN, and basically you know the order of UN is nothing but phi n Euler's phi function. Okay, and phi n gives the total number of elements in U30. So you can see 1, 7, 11, 13, 17, 19, 23 and 29. So we can see this much of elements are there in U30. And out of these elements, we have taken 1 and 11, which makes a subgroup over here, which is certainly the subgroup of this U30. And then you have to find what? Then you have to find the left quotients, and here the distinct left quotients of H. If anybody is there, then certainly they are welcome to give the right answer for this question. Okay, just a second. Yes. So how shall you find it? So first of all, you must see one thing over here. Here you can say what? Clearly your H is what? The proper subgroup of G. Why? Because in G these elements are over there 1, 7, 11, 13, 17, 19, 23 and 29, and out of that only 2 elements has been taken as 1 and 11. So we will certainly say that H is the proper subgroup of G. Therefore, what shall you do? You will, if you want to write the distinct left quotients, then certainly you will take the elements from G, which is G is U30 over here. So you will try to write the left quotients with the help of the elements from U30 other than 1 and 11. And other than 1 and 11 elements will be selected to write the left quotients. So certainly we can see that this 7 does not belongs to this H. All right, the 7 does not belongs to H. So certainly we are able to write a left quotient with the help of 7. So what shall you write? 7H. So 7H means what? 7, and the elements are what? 1 and 11. So certainly what binary operation you will take? So you must remember that you are talking for this group U30, and therefore you should take the binary operation at multiplication modulo 30. Okay, so now this is 7 into 111, because this is how we are going to write the left quotients. So here it will become 7, and 11 into 7 is 77, and if you are going to divide that by 30, then what the thing will be there? What shall you say? What the thing will be there? Because 77 is there, and you have to divide with what? 30, and then you can see 17 as the remainder. So another element will be what? 17. So as you have generated your first left quotient with the help of this one, Ashish ji, you are welcome. So as you are able to see that good evening Ashish ji, you have passed this question, but you can see that this is how you will write 7H. Is this fine? Is this clear? Because you have to write the left quotients of H in U30. So we have to take the elements other than 1 and 11, and we must have to write the elements like this, 7H. So it will become 7 and 17, these 2 elements. So now you have to generate other left quotients with the elements other than 7 and 17, because you have already used this. So as you have to find distinct left quotients, therefore you will not use 7 once again. So this is 7H. So elements will be 7 and 17, only these 2 elements. And now if you want to write another quotient, then in that case you have to take the elements from U30 other than 1, 11, 7 and 17. Out of these 4 elements, except these 4 elements, you have to choose other elements. Okay, and in that case, what shall we take? We shall take 13. Because 13 does not belongs to, neither belongs to H nor belongs to 7H. So that's why we will concentrate ourselves for the left cosets like this, 13H. So it will become 13, 1, 11. So now what shall you do? It will become what? 13. And if you will multiply this 13 with 11, and then if you will divide with 30, then the remainder will be 23. So this is your second left quotient, 13H. So now if you want to write another left quotient, then you have to take the elements other than 1, 11, 7, 17, 13 and 23. So what is that element? You will not hesitate to say that as this 19 does not belongs to H, or does not belongs to 7H, or does not belongs to 13H. Therefore, we will be able to write 19H, because 19 does not belongs to either in H or in 7H or in 13H. Therefore, it will become what? 19. So, what shall you do? 19 into 1, 11. Once again, when you are going to multiply this 19 with 1 and will divide with 30, then you will get 19 only, because 19 is less than 30. And when you are going to multiply this 19 with 11 and then will divide by 30, then you will get what as the remainder? Undoubtedly, you are going to get remainder as 29. So here, what can you see? So from here, we can easily see that when we are taking the elements from H with 7H, elements with 13H, union elements with 19H, then finally when you are going to take the union of all these, then you will see that this H is what? 111, 7H is what? 717, 13H is what? 1323, 19H is what? 1929. So finally you are going to get U30. Okay, so hence you can say what? These are the distinct left quotients. If you will try to write any other quotient, then that left quotient will be any 4 of these only. So we have only these 4 distinct left quotients. Is this clear, Ashish ji? If you are over there, then please let me know. Is this fine? Is this clear? So finally, what shall you say? Option D is absolutely right, because the group was given and you have to write the left quotients, and which is here you can see. So I hope this is clear beautifully. And now the next question, which is completely based on the geometrical description, is over here, and you should try your level best, because we just want to visualize the concept of quotients in term by using some geometry. Very basic question. Intuitively you will be able to say the answer within seconds, but will you really do it? So let G be a group of non-zero complex numbers under multiplication, and H is what? X from G, such that mod X is equals to 1. Then what is the geometric description of the quotients of H? What would you like to say? So don't worry, it is completely based on the very basic definition. Okay, so you don't need to worry at all. You will be able to do it within seconds, and it will give you a clear-cut picture of quotient, what actually means. What is the actual meaning of quotients will be there in front of you after doing this. So intuitively I will give you the answer within seconds, but we'll do the clear-cut proof as well. Waiting for your response. You may write pass. If you want a quick solution, then you may write pass. And this time Ashish Tiwari ji is there and he is absolutely right. Because he can easily observe that the elements from H, okay, which kind of elements from H? So you can see H is nothing but x from Z with mod x is equals to 1. What does it means? If x is a complex number, then for example it will be of this type, u plus iota v. Then mod x is equals to 1 will give you what? U squared plus v squared is equals to 1. Certainly a unit circle, isn't it? Yes, a unit circle. You will just get the unit circle, which is over here. And what about the quotient? Quotient means what? Quotient means A into H, isn't it? Just give me, let me do the explanation. It will take not more than 2 minutes. You can see your clock. So it is what? Watch or clock, whatever. So AH is what? AH, where what shall we write? Where H belongs to H. This is how we used to define the left quotients. And we have to show what? This is equals to, this is nothing but Z belongs to non-zero complex number such that mod Z is equals to A. If we are able to see show this one, it means what? For intuition, I would like to say, if you are given an unit circle, okay, if you are given an unit a set of unit circle, you can say as the subgroup, then you can see what? If you want to write AH, what does it means? So unit circle is given, but if you will do AH, then you will get a circle of radius A. And in that case, you are getting nothing but a set of concentric circles, isn't it? And this is what I am just going to prove it within 2 minutes. Okay. So yes, mod Z is equals to mod A. All right. So what shall we do? We just need to take, let x belongs to AH. Take it from the subgroup. It means what? Certainly we will have some H in capital H, so that x will be equals to AH. Good evening, Prashantji. You are welcome. For some H in H. And from here you can easily write A inverse x is equals to H, which is certainly belongs to H, being subgroup. By using subgroup criterion, we can easily see A inverse x, which is equals to H. I would like to say H belongs to H, and H is written in terms of A inverse x. Therefore, certainly this A inverse x belongs to this H. Okay, and now what can we see? Mod x is equals to what? What do you think? It will be equals to mod A. Why? Because mod of H is equals to 1. Isn't it? From here we can come over here. Okay, because we can just take A. We will multiply and mod of H is equals to 1. Therefore, mod x is equals to A. So from here we will not hesitate to say that our x belongs to Z belongs to G, such that mod Z is equals to mod A, which gives what? A set of concentric circle to unit circle. This is nothing but a set of concentric circles with the given unit circle. Okay, so that's why so this is the geometrical description of this question. So I hope this is clear. Now the one more question is over there and completely based on the geometric description as the quotients. So you can see G be the additive group R cross R. Okay, so what is your group over here? R square, you can say. And the binary operation is certainly addition. What is H? A special kind of ordered pairs. I mean to say y is equals to x. So certainly geometrically you will be able to understand what this H is. But I will not reveal it now because you have to give the right answer, and thereafter you will get a clear-cut intuition to say the things within seconds. Okay, so be a subgroup of Z, then the geometric description of cosets of H is given by what? Okay, so in the previous question you had seen the circles over there, and now in the options you can see circles, parabolas, straight lines, and none of these. What would you like to say about it? And this time Ashish Tiwari ji is there, and he will not hesitate to say that he has given the idea from this question, because the group is what? R square with respect to addition. Okay, and what is the subgroup? So here subgroup is what? X comma X, where X belongs to R. What does it mean? So X comma X, it means this is nothing but the straight line y is equals to X, because whenever you are going to insert X, you are going to get output as X as well. So the elements are nothing but the points on the straight line y is equals to X, isn't it? So this is the subgroup according to the question. And if you will do what? If you will multiply your H with any number, because this left coset means what? A into H. A is what? A number. So AH, then what the things will happen? Certainly you have to translate this straight line, and then you will get the cosets, isn't it? So translation of this straight line only. Okay, so certainly that's why you will not hesitate to say that we are going to get the straight lines only. Okay, and analytically you will certainly prove it easily. So that's why the final answer is C. So I hope you will do it for sure. And this time Shivani Verma is there. Shivani, for this question the answer is a straight line, because the subgroup is going to be obtained with the help of this straight line passing through the origin. Okay, the straight line passing through the origin. So if you want to give the geometric description of the cosets, then when you will just multiply with AH, for example, if I would like to say that there is no need to multiply because additive things are over there. So for example, if you will take the elements like minus 2 comma 3 plus H, then this will be one of the left cosets, and certainly you will not hesitate to say that for this kind of a straight line, certainly the points minus 2 comma 3 will be somewhere like this. Okay, so this kind of things will be there, because here the group is additive, therefore the left cosets will be of this kind, A plus H. Okay, in the previous question we had seen a set of circles as the cosets, but here we are going to see a family of a straight line as the cosets. So I hope this is clear, I hope this is fine. Intuitively it is proved, but if you will tell me to prove it by writing everything, then you can do the comment and will do accordingly. So do you need the proof of this in a proper way, or intuition is fine? क्या आप इंट्यूशन से ही खुश हैं, या जैसे मैंने इसका प्रूफ दिया उसी तरीके से आप इसका भी प्रूफ देखना चाहते हैं? अगर देखना चाहते हैं तो कमेंट कर दीजिएगा, है ना? इंसान तो डिटेल में ही पढ़ाना चाहता है। अब मैं यहाँ पे ये बात करना चाहूँ इस क्वेश्चन के लिए। फॉर दिस क्वेश्चन, sorry, this is not a question, this is just a recall. Don't worry, I will not tell you about the proof of Lagrange's theorem, because you all are over here for only competition point of view. I really understand your concern, so I am not going to give the proof of this theorem, but certainly I would like to focus on its statement, its use, and in which condition this theorem, this Lagrange's theorem has its converse true. Okay, so the order of any subgroup of a finite group is the divisor of the order of the group. Okay, you can easily prove it with the help of the quotient. The proof is over here, but in our graduation days we had already done it. And what is the index of H in G? Okay, so index of H in G is denoted by this, and this is nothing but the number of all the left cosets of H in G. Okay, so you all know these notations already, and we also know the index of H in G is equals to the order of index of H in G is equals to the order of Z divided by order of H. Okay, we also know one more thing, that converse of Lagrange's theorem is not true always. It is true sometimes, not true sometimes. Which condition will be added, then we will always say that Lagrange's theorem is true. Certainly we will put a focus on that also. But before coming to that, this example is very interesting, that A4 does not have a subgroup of order 6. Okay, and you know the order of A4 is what? Order of A4 is what? Certainly factorial 4 by 2, alternating group. So factorial 4 is 24 divided by 2, so its order is 12. 6 is going to divide 12, but A4 does not have any subgroup of order 6. What does it mean? Lagrange's theorem is not true always, because here is a counter example. The proof is over here. I will send this PDF to you, and if you will be able to, if you will tell me to explain why, how this has been done, then certainly we will make a special video on that. But this session is completely dedicated for the questions. Okay, and yes, the question is coming. A very interesting question on Lagrange's theorem is about to come. But before coming to that, I would like to read this, that okay, for cyclic groups and finite abelian groups, the converse is true. Okay, you cannot say that converse of Lagrange's theorem never holds. You cannot say. You will say sometimes it holds, sometimes it does not. But if we will discuss Lagrange's theorem on a cyclic group or finite abelian group, then the converse is always true. But with the condition, now the question is over here. This is completely based, and I would like to say 4.75 type question. So you have to be very, very careful for this question. Okay, very, very careful. Completely based on Lagrange's theorem. If you know Lagrange's theorem beautifully, then nobody can stop you to give the right answer of this question. So I will give you appropriate amount of time to say the right things. Suppose that K is a proper subgroup of H and H is a proper subgroup of Z. K is a proper subgroup of H and H is the proper subgroup of G. This is given. If order of K is equals to 35, its order is 35 and order of Z is 700, then what would you like to say? Okay, 4 options are there, and I would like to say 4.75 type question is here. Either you will get 0 or you will get 4.75. Okay, just 1 or 2 line justification, but will clear the concept. You may write pass also if you don't want to waste your time. If you want to think, then take your time. And this time, Prashant ji is there with the answer, but I would like to say, Prashant ji, you are very close to get 4.75, but for now, I will give you only 0. Okay, proper word is also meaningful for this question, Prashantji. So you have to be a bit careful. Yes. Proper subgroup. Proper word is meaningful for this question. So you have to take care of it also. Yes. Shivani is saying B, but Shivani, more than one options are correct. Okay. And proper word is over here. So how can you say B? K is a proper subgroup of H. It means what? Okay, so we must have to be a bit careful. Anybody will write pass, then I will start the discussion. Ashish ji, I am waiting for your response also. Nobody has gotten 4.75 up till now for this question. And this time Ashish Tiwari ji is there and he is absolutely right. So congratulations Ashish ji. A, C and D are the right answer. Certainly we know the order of K is 35, order of G is 700 and let's say order of H is equals to M. Okay, order of H is what? Equals to M. Then by Lagrange's theorem, what would you like to say? K is the proper subgroup of H. Then will you hesitate to say that this 35 will divide this M by Lagrange's theorem? And this 700, I would like to say this 700 will be divided by this M. Are you people agree with this? From Lagrange's theorem, being the subgroup of H, the order of K will divide the order of H and the order of H will divide the order of G. So 35 should divide M and M should divide 700. So what shall from here what the conclusion is? Certainly we will say M is a multiple of 35. M is a multiple of 35 and at the same time it should be the divisor of 700 and a divisor of 700. Okay, so now how shall you write this 700? You can write this 700 as how? Yes, please tell me. 75 into 20, things like this. And what are the possibilities? Thus the possible values of M are what? From here what the conclusion are? Possible values of M are what? What would you like to say? Certainly you will say either it will be 35 or it will be 2 into 35 or it will be 4 into 35 or it will be what? 5 into 35 or it will be what? 10 into 35. Isn't it? Okay, so these are the possibilities. So because 700 can be written as 35 into 20. So the possible values of M, we are talking about M. Okay, so that M can divide this 700 and will be the multiple of 35 as well. So by considering those two conditions simultaneously, we will be able to say that the possible values of M will be what? Either 35 or 70 or what? 70 into 2, so 140 or what? 175 or what? 350. But do you know one thing? That as the word proper was also mentioned, and that's why we will eliminate this 35 wala. Because if we will take 35 as M, then in that case K will not be the proper subgroup of H. So as K is the proper subgroup of H, so that's why we are not considering this 35. Otherwise we don't have any problem. So yes, what are the possible values of M? 70, 140, 175 and 350. Okay, and that's why we will not hesitate to say that yes, there is a possibility that H is of order 70, there is a possibility that H is of order 140 or 175. Possible orders of H are 70, 140, 175 and 350. So here you can say A, C and D are the correct options. I would like to say, so we are here on up till Lagrange's theorem. I would like to say on this channel up till Lagrange's theorem everything has been discussed, but we will try to understand many more things with the help of the questions. So the questions that has been solved this evening, this kind of question number 4, you will be able to see many questions that has been asked in GATE, CSIR, NET, okay, and some fresh questions as well. But tomorrow at 8:30 p.m. Yes, tomorrow is also a class at 8:30 p.m. So we are going to meet tomorrow at 8:30 p.m. on this channel only. Okay, so we'll see you tomorrow at 8:30 p.m. Till then, take care. Bye bye. I would also like to say that real analysis has been completed on this channel already. Certainly you may watch that lecture series, that will really help you on YouTube. Okay, more than 90 videos, more than 100 hours lecture, complete course is over there. And I will also come up with a set of questions on real analysis for practice. Okay, so we'll see you in the next class, which is tomorrow at 8:30 p.m. Till then, take care. Bye bye. Thank you very much everyone for joining live, and you may share these sessions to the needy as well. Okay, so we'll see you in the next class tomorrow at 8:30 p.m. Till then, take care. Bye bye. Good night. Jai Hind, Jai Bharat, Vande Mataram. Thank you very much. Good night, Ashish ji, and everyone who is watching this lecture right now.